Hey, welcome back to my channel. And welcome to chapter two of the cross origin resource sharing course. And if you attended chapter one, you'll remember that we left off the web application overview with a mention of another concept that is very important and foundational in understanding cross origin resource sharing. So, that concept is called same origin policy. So, what is same origin policy? It is an HTTP security policy that dictates that if a script is downloaded from one origin or URL more broadly, then it should only be able to exchange data with that URL. So we're using the word URL or web address here loosely, but the correct word to use is origin. So what exactly is an origin? So an origin is a subset, we could say a subset or a child of the URL, such that when we have a URL or a web address, we only consider the scheme, the host, and the port to constitute the origin. So if we have like www.facebook.com, then the host, if it's an HTTPS, sorry, the scheme HTTPS, the host facebook.com, and the port, whatever it is, will form the origin, regardless of what else is on the URL path. So a scheme, a host, and the port must be identical between two web addresses for them to mean the same origin. So having looked at that, we can look at another diagram I drew to help us understand this concept better. I want us to go through this together and try to practice the same origin concept. And hopefully you can work with me and have a cleaner understanding of this. So let's look at one web address, localhost port 8080 on HTTP. Let's treat that as our first origin. And if we look at the second one here, and you compare to that, do you think these two are the same origin? The answer is yes, because the scheme, HTTP, the host, localhost, and the port, 8080, are the same, are identical. So these form the same origin. What about this? If so, the URL here and the first one look really similar, but this particular one I'm highlighting has a path parameters. So API slash users is appended to that URL. Well, the question is, do they form the same origin based on the scheme, host, and port tuple? We can tell that this is the same origin as the first one. And then we have another URL here which has not which looks in many respects similar to the first three, but it has the API path parameters, and then also a query parameter, one query parameter. So when we ask again, is this the same origin as this? The answer is yes, because the scheme is the same, HTTP, the host is the same, and the port is the same. We don't really care about the rest of the URL. So then let's move to the next one where we've changed something more fundamental. So here, two of the fields are the same, but the third, the port, is not the same. So is this the same origin as this? The answer is no, because the port is different. Remember, we consider scheme, a host, and the port. Then something more complicated here, we've changed the domain from localhost to api.example.com. So is this the same origin as this? The answer is no. On very many fronts, they even don't look similar. So the scheme is the same, but the domain is not the same. So that even by just looking at it with the eyes, it's already different. And then we have another example where we change the scheme. So look at this instead of the first one there. The scheme has changed. It's HTTP versus HTTPS, but the domain is the same. Uh-huh. The domain is the same. api.example.com, api.example.com. But these are not the same origin. Reason being, we have a different scheme. And then the last example here, Let's compare it to this. The scheme is the same. The host looks the same-ish, but we've put this one on a different subdomain on the same host. So the moment you change the subdomain, that's no longer the same host in same origin concepts. So these two are not the same origin. So I hope after looking at this, you now have a pretty good understanding of what we mean when we say origin, and when we say same origin, what we do mean. And I hope you'll be able to compare different URLs and tell which are the same origin and which are not. Yeah, so after this, the next section I want us to cover is a look at the original diagram we covered in the first chapter. So for those that attended it, you'll notice that this is more or less the same architectural diagram showing two variants of a web application. On one side, there's an MVC application. On the other side, there's a single page application communicating with a separate server. So there are some differences here. For example, initially I labeled this backend, but now I've identified it with its URL or its origin. And then where I separate the front end and the back end, I've also, instead of labeling them front end and back end, I've labeled them with their origins or their URLs. So, and then the third party services, I've also used their origins instead of their URLs. Sorry, instead of just saying third party services. Okay, so let's just review what we had gone through. So we said that in a typical MVC application on this side, we will have one server that will serve both front-end and back-end resources. So if a user types this URL in the address bar of the browser will make a request to the server, and the server will respond with all the static resources that are needed to render a front-end for it. So the browser may further evaluate third-party resources referenced in those static resources and call third-party servers to fetch them and maybe cache them locally to help it optimize and not have to fetch them again for every request the user makes. So, another difference I didn't talk about is the arrows. Some are green, some are red. Originally, they were all black. So, whenever you see red, that is a cross origin request and it violates the same origin policy theoretically. It's more nuanced than that, but we shall explain shortly. So in the first MVC example, we have subsequent requests coming from the browser, maybe a JavaScript request or something similar. And in this case, since we loaded the resources from localhost 8080 and the request is going to localhost 8080, that's the same origin request. It doesn't violate the rules. However, to the third party services here, we are violating same origin policy because we downloaded files from localhost 8080 and now we are calling APIs on ajax.googleapis.com. There's a change in origin and that is a same origin policy violation. And then going on to the SPA example, it's even more interesting because now this is no longer only third party services. We have our own front end server here. Maybe it's running React on Nginx server, and then a backend service here running at this origin. And whenever we fetch the user will typically type the front end URL and then the browser will fetch resources from the Nginx server. And in those resources, it might resolve third party resources, but more importantly, it will make API calls to the API server, probably to perform some operations based on user action. So just imagine that these are both our servers, but this request is considered a violation of same origin policy because we fetched the resources from localhost 3000 and now we are making API calls to localhost 8080. So, but we need these requests. So this is another really interesting thing. And of course, we can accept that third-party API calls will be considered violations of same origin policy. So after going through this, I'd like to mention that not all requests that are cross origin are actually violations of same origin policy. And to drive that point home, I want us to look at another um, something else I prepared. So here on the screen, we have an index.html file. So just assume that among the resources fetched from this server and maybe this React server is an index.html file that contains this code. So I wanted to highlight that you can see here we are resolving additional resources linked in the HTML files downloaded from our servers. And these resources live in third-party services. So for example, this is in Bootstrap CDN, we are fetching Bootstrap CSS files, and then this as well. And then we are also fetching fonts from Google. This is again not our server, this is a third-party server. So these are all cross-origin requests. And then we have jQuery here, we're fetching. This is the script we're fetching. And these are all cross-origin requests to get more resources for our web application. And if you go further to the body of the HTML file, you'll see a form that collects only one field and makes a submission. So this form talks to another API, which is different from where we fetched our resources from. This is also a cross-origin request. However, it's not violating the same origin policy because this is not a script request. For a data exchange to violate the same origin policy, it needs to come from a script. All right, it needs to come from a script. But fetching the script itself is not a violation of same origin policy. So I hope that difference is clear. And then we can go back to our diagram. So that means that some cross-origin requests are very important, like resolving third-party resources. And then in this example, our front-end service is served from a different server as the API service. So what does this mean? What this means is that there are some these are the nuances I was talking about. So we really actually need those resources. For example, we need the JavaScript here to be able to interact with the API because that's the real purpose of the web application. We only separated our React server from the backend server. So this is a good use of cross-origin request. But the browser, by default, does not allow cross-origin requests because of the same origin policy. So what does that mean for our use cases? Now, based on this, I want to talk about the reason why we have same origin policy, and I have another box here that will help us just walk through them one by one. So let's just review the security risk aspect of cross-origin requests. So let's remember one thing that when the browser fetches files from the server, it might cache them, but besides the static resources, it might also have um, session information. For example, if the user has already logged in, then the backend server will send a session cookie that the browser will cache here locally. Okay? Just like here, after logging in successfully here, assuming we set this up correctly, then a session information may be stored here. What does that mean? Session cookies are used by browsers to track user action across different requests. So that when you send one request to the server and you send a second one, the server can know that this is the same user and maybe give you a better experience. For example, in shopping carts or banking, and you want to do a couple of transactions and you don't want to be logging in every time. So session information will help the browser and the server track who this user is. So, and then based on also how browsers work, modern browsers are somehow mandated to capture this session information and send it alongside any request from a script on the browser side. So that means that whatever script we downloaded from here and is able to make calls to our API, If it's already an authenticated session, then the browser will have stored a session cookie locally. Now, when a user clicks something or on the browser and a request is sent to the API server, the browser will attach the session cookie behind the scenes so that the server can know that the user sending this request is a user that already authenticated. So that is a loophole that is very easy to exploit for a lot of hackers. And another fact you need to remember is that we've just looked at the fact that not all cross-origin requests are blocked or in violation of same origin policy. So just like we saw HTML tags that are fetching static resources, JavaScript files are not considered violations of same origin policy. It's only when those scripts make requests to the server that they are considered violating the same origin policy. So this particular feature is a major loophole as well that hackers can use. So that means that now let's change our attention to here. Now we're talking about malicious scripts. We've talked about the safety of HTML tags fetching resources. So a malicious script could be injected in the HTML tag. All right. So assuming the browser has fetched resources from the Nginx server locally, and among those there is another URL. Okay, that these are all our files. Okay. So let's say the user has already fetched these resources and interacted with the server and authenticated himself, and now there is a session cookie stored in the device storage. Then, without logging out, the user goes to another web page in another tab. And that web page is actually managed by a malicious actor. So, what will happen is that web page may download third party resources from a malicious CDN server, perhaps. I've called this unsafe JS just to reflect that point. So, when this JavaScript is downloaded to the browser, remember that every request to the API from a script within the browser will check if that API has session cookies stored already. Meaning it will ask itself, does this API already have an authenticated session in my browser? Then if so, theoretically, it's supposed to attach the session information for any request that goes to that API. So if the request is coming from a different, well calculated JS file that is malicious, then the browser theoretically is supposed to attach the session information for any request. If the malicious actor has written code that interacts with this API server, then the browser will attach the session. This is called session riding because the session was created for scripts within this browser that had originated from this origin. But now, this malicious script will ride on top of that advantage. And in case they know how to make requests to this API server that are malicious, maybe to steal data or to make bank transfers, then they will have been successful theoretically. Okay, so this is where same origin policy becomes important and critical because then scripts from different sources because you don't know what the user is going to load on their browser. So any script would be able to make requests to this API server and ride on top of the session that was got for the authenticated page. So this is a risk that same origin policy saves us from. So we can even look at how to do that, assuming this is our legitimate page. All right. And then there's another page, let's say that doesn't get jQuery, but gets maybe a page, a JavaScript like this. So if this script is fetched from another page that the user visits, and instead of having this form submission, there's a button in it that somehow lies to the user that they're filling in their OTP field here or whatever, And instead of calling this a submit, it has an on-click callback. And this one, let's call it cash transfer. Okay, just something like that. I hope you get the point. So cash transfer is a method which is inside this JS file. And if this HTML is successfully downloaded to the user's browser because they visited another site, then that particular site will be able to download, the browser will be able to download this JS. And when the user clicks that button somewhere and this method is triggered and it knows to communicate to the API, so assume whatever we've put here is a script that came from this third party, all right? Whichever the case, but the script is already in the browser and it has tricked the user to click a button. And then the cash transfer method has been invoked from here. And that method knows how to communicate with the API and it understands the API and is able to do a malicious action. Then the browser, without same origin policy, would attach the session that the user had got from a legitimate interaction. And this session will allow the script to do the actions because the server will not know, okay? The server will not know that this action is coming from a malicious script because it has a session that was stored, that was sent by the API server. It has it available in the browser, and that request has the session available in it. So the API server will respond positively, and that will be a successful hack. So this is the key and critical point why same origin policy is very important. And now, after seeing that, it's very important for us to realize that much as there is the heavy risk, but there's also huge advantages of cross-origin requests. Okay, for example, we right from the previous chapter, we saw that it's important for browsers and web applications to be able to interact with third-party services, typically to enrich the user's experience. So, fetching extra resources from elsewhere or fetching resources from CDNs for optimizing users' experience. For example, if the application is running in maybe US and the user is located in perhaps in Europe, then there might be CDNs for the owner of this web application that are located in Europe, and it will load faster. The browser will load faster if those resources are fetched from nearby servers. So this is there is no web application I know of that only depends on its own resources. They could fetch CSS from Bootstrap CDNs. They could fetch jQuery from Google CDNs. And all these interactions need to be governed. They're all cross-origin requests. But then, and additionally, a lot of applications now separate the front-end and back-end servers. So, don't you think that they need a way to communicate for scripts fetched from the, let's say, the Nginx React server to communicate with a backend service? Okay, the scripts need to communicate, but same origin policy lies in the way. So that brings us to the end of this chapter, and I'll part by saying that we've seen the risks of cross-origin requests. We've understood the same origin policy. We've looked at the risks that the absence of same origin policy would pose, and as an extension, the reason why we have same origin policy. We've also looked at an example to just demonstrate theoretically what might happen without the same origin policy. So, with all these things happening, the question is: so what do we do? So, we have these browser security features and policies, but also we have other policies to govern cross-origin interactions between web applications. And this one of these is called cross-origin resource sharing. So this is the fundamental concept I wanted us to cover, same origin policy, to lay a foundation for us to explore cross-origin resource sharing. So with that being said, in the next chapter, I'm going to dive into cross-origin resource sharing and see you then. Thank you.